Hello everyone, today we are going to start a new subject, that is algorithm. So today we are going to start the subject algorithm. Now look, you are here, that means you want to be a good computer engineer, that means you want to be a good software engineer. Now what will be the task of a software engineer? That is, a problem statement will given to us, and our task will be to convert this particular problem statement into computer program. This is our goal as a software engineer. This is our main task as a software engineer. Now, what is the problem here? The problem is this particular given problem statement, we need to convert it into equivalent computer program so that in digital system we can solve that particular problem. That is our problem statement. Now there is one challenge, that is how to convert this particular problem into a computer program so that it will be a good computer program. That means because of that, first our task will be to write algorithm for this particular problem. To write algorithm in this for this particular problem. Now what is algorithm? Algorithm means how or what are the steps that we will use to convert this particular problem into a computer program. Write down all the steps, all the necessary steps in step by step. That is called a algorithm. Now there is one thing, that is there may be more than one approach to solve or to convert any particular problem statement into computer program. That means there is a possibility that we have more than one algorithm for a particular problem to solve that particular problem in digital system. That means this particular problem may have more than one algorithm. Let's say algorithm 1, algorithm 2, algorithm 3, like that n number of algorithms are there to solve this particular problem. That means in using any of these algorithms we can convert this particular problem into computer program. Now among these n algorithms, which one to use to convert this particular problem into computer program? Now that means now we have n number of choice to ask which one to use. That is the question. Now that means what we need to know, what we need next we need to compare all these algorithms. We need to compare all these algorithms and we'll select the best algorithm. To convert this particular problem into computer program. Now what will be the criteria based on which we compare all these algorithms? What are the criteria based on which we compare all these algorithms? There are two criteria in which, or by using which, we can compare two or more algorithms to decide which one is best for computer program. That means which one will perform best in digital system. So What are those criteria? To compare these algorithms, we will use one approach that is called time complexity. And the second approach is space complexity. Now, what is this time complexity and what is this space complexity? Now, time complexity defines time required to execute. That means the total time required by an algorithm to execute the operation. That is called time complexity. And what is space complexity? Space complexity defines the total memory space required for processing the algorithm. That means space complexity defines total memory space required for processing the algorithm. Clear? That means time complexity defines the total time required for execution, and space complexity defines total memory space required for processing the algorithm. Look here, space complexity defines the processing only. For processing, how many memory space required? That means the memory space required for input and output will not considered for space complexity. Other than input and output, how many extra memory required to process the algorithm is called space complexity. Other than input and output, how many extra memory required for the processing of the algorithm is called space complexity. So, based on this time complexity and space complexity, we will compare all these available algorithms for a particular problem and select the best one. Now, how to define the best one? That means the algorithm which takes less time and less memory space will be select. That the algorithm that will execute in less time and it takes less memory space will select for this problem to convert that problem into computer program. Clear? That is how we will compare the algorithms by using this time complexity and space complexity. Now, how to find the time complexity of an algorithm and how to find the space complexity of an algorithm? Now we are going to learn that thing. So, first we will see time complexity. What is time complexity? That means total time required. Total time required is called time complexity. Now, to define the time complexity or to calculate the time complexity or how long a particular algorithm will take to execute, we have three different notation. Three different notation used to find time complexity of an algorithm. Those notations are called asymptotic notation. Asymptotic notation. That means how many asymptotic notation are used to find the time complexity of an algorithm? We have three different notation. What are those notation? The first notation that we used is called big O notation. The second notation that we use is called big omega notation. The third notation that we used is called big theta notation. Now, what is the symbolic representation of all these notations? Big O notation is represented by big O. Omega representation is represented as big omega. The big theta represent as big theta. Clear? This is the three different notation that we are going to use to find the time complexity for an algorithm. Now, what is these three notation? Look, when to use these three notation and when to use which notation. First thing is that when to use which notation. Look, the big O notation is used to represent the worst case time complexity. Worst case time complexity. The big omega notation is used for best case time complexity, and the big theta notation is used for average case time complexity. Average case. Now, what is this worst case, best case and average case? Look at here. First one is worst case. What is worst case? Worst case define the algorithm will take at most this many time. The algorithm will not going to take more than this time. That means this is the upper bound of time. The algorithm will take at most this time. The algorithm will not take more than this time. More than this time. This is called worst case time complexity. That means this is the upper bound of time, and upper bound of time, that means the algorithm will take at most this time, and the algorithm will not take more than this time. This is the upper bound. Clear? So next thing is, what is big omega? That means best case. Best case means this one is the lower bound of time, and this means the algorithm will take at least this time, and the algorithm will not take less than this time. This is called the best case. That means we need minimum this many time to execute the problem. That is called our best case or big omega notation. That means big omega notation is represent these concepts. Now, what is big theta notation or average case? Average case define. What is average case define? Average case define the average time taken by an algorithm. By an algorithm, and we generally use this notation to represent the time complexity when for any particular algorithm best case and worst case are same. At that time we generally use this big theta notation, that means represents when the worst and best case time complexity is equal for any particular algorithm. At that time we will use this big theta notation. Now this is our best case, average case and worst case. Now in generally which of these three notation is used to compare the time complexity. Now look one important thing, that is the time taken by an algorithm depends on the number of inputs. Clear? The time taken by an algorithm depends on the number of inputs. Now if number of inputs is more, then time increase. Clear? But if the number of input is less, at that time the algorithm also takes less time. That means we always compare for a large number of inputs. That means we will see how the algorithm execute when the number of input is large. For a large number of input, how many times an algorithm will take to execute the problem, that we will consider. That means we basically consider the worst case time complexity. What will be the maximum time that the algorithm will take to execute? We will compare all the available algorithms based on that concept. That means based on the maximum time required to execute the algorithm. So hope you understood how these three notation is used and when and which one is used to compare the algorithms. We will compare the algorithms for a large number of inputs. That means when the number of inputs is large, at that time we will see how long it will take to execute the algorithm, and based on that particular time complexity we will compare all the algorithms. Clear? Now why we consider only large number of inputs? Look here, as the number of input increased, we know the time also increased. The time an algorithm will take, that also increase. Because of that we will take the maximum time that will be taken by an algorithm. We will focus only on that part, not the case where the number of input is less. And we know in case of less number of input, the algorithm will also execute very fast. That means the time taken by the algorithm will be very less. Clear? So we will not consider that thing, that thing, and we will consider the case where the number of input is large. Clear? So this is it for this class. In our next class we will learn big O, big omega and big theta notation in details. Thank you. See you soon in our next class.